In this unit, we will study Basics of Software Requirement Analysis. The unit is organized in this way. First, we study what is software requirement analysis. Then we briefly introduce how software requirement analysis is conducted. Second, we will study major areas of effort during software requirement analysis. Third, we will discuss 3 requirement gathering techniques: meeting and interviewing, facilitated application specification technique, quality function deployment. Fourth, we will talk about software requirement analysis principles. Fifth agenda item is prototyping for purpose of requirement gathering. And lastly, we will discuss software requirement specification and representation principles and how to prepare the software requirement and specification document. After completing this unit, you should be able to: Number 1. Understand what is requirement analysis. Number 2. Understand tasks performed during requirement analysis. Number 3. Explain different techniques of requirement elicitation. Number 4. Comprehend analysis principles and their application in requirement engineering. Number 5. Understand software prototyping in the context of requirement engineering. Number 6. Understand what are the requirement specification principles and how user requirements should be specified. Dear students, let us begin with what is software requirement analysis. Software requirement analysis is a process of collecting, understanding, modeling and documenting the software requirements which are essential to develop high-quality software. Mostly software engineer is responsible for the task of software requirement analysis, but in case of complex systems, this task is performed by the specialist commonly referred to as system analyst. It is the job of the system analyst to extract the exact requirements from the customer and specify them in a manner in which these requirements can be translated into software design. Software requirement analysis is the first step toward quality assurance. All the parameters of quality with respect to particular software should be clearly identified and specified at this stage. If software is being developed without clearly establishing the requirement, more often than not, the developed software will be solving wrong problem and it would be a waste of time, money and efforts. Let us focus on how this complex task requirement analysis is performed. System analyst begins with identifying externally observable data, functional and behavioral requirements. Data objects are either produced or consumed by the system. Example of data is employee record and salary slip. Functionality refers to software's ability to process or transform data. Maintaining customer record is an example of software functionality. Software behavior implies how it works under certain conditions. In other words, how software reacts to certain input or action or command. Example of software behavior is that when an employee data is being updated, no one else can access that data during updation. The second task of the system analyst is to create data model, functional model and behavioral model. Let us go more into details of requirement analysis. Logically, Software requirement analysis can be divided into 5 major areas of effort, all being equally important. These areas are: number 1, problem recognition; number 2, evaluation and synthesis; number 3, modeling; number 4, specification; number 5, review. Let's look at each area one by one, starting from problem recognition. In problem recognition, the goal is to recognize the basic problem as perceived by the user or client. The analyst studies the project plan in order to determine the scope of the software. System analyst, after doing his initial homework regarding size, scope and application area, establishes communication with the customer so that problem recognition is ensured. Problem evaluation and solution synthesis is the next major area of effort. In it, the focus is on what, not on how. For example, what data does the system produce and consume? What functions the system must perform? What behavior does the system exhibit? Which interfaces are defined? And what constraints apply? Third area of effort is modeling. During the evaluation and solution synthesis, the analyst creates models of the system in an effort to understand data and control flow, functional processing, and operational behavior. These models serve as a foundation for software design and as the basis for the creation of software specifications. Fourth area of effort is specification. The software requirements specification is a document that is produced as a result of analysis. The functional, behavioral, architectural, interface and performance-related requirements of the user are defined in the form of a complete formal document. Fifth area of effort is review. In the requirement analysis, a review of software requirement specification (SRS) is conducted by both the software developer and customer to ensure that both have same perception of the system. Dear students, let us study now how to gather the software requirements from the customer. Software requirement elicitation is the difficult part of the requirement engineering phase. A lot of communication between customer and system analyst is required. Opportunities of misunderstanding and misinterpreting are many. It is difficult to start the communication lines with the customer. However, there are a number of techniques to gather software requirement. In this unit, we will study 3 techniques of requirement elicitation. Number 1, meeting and interviewing. Number 2, facilitated application specification techniques. Number 3, quality function deployment. The most common requirement elicitation technique is meeting with customer and customer interviews. There is no specific requirement for conducting this kind of interviews and meetings. Such meetings can take place at development site or at customer's place. The focus is on that all the stakeholders should record their requirements and concerns. Requirement gathering is an iterative process, and in this way, more customer participation is required. When at the end of requirement analysis stage, software specifications are produced, final check of correctness, completeness and consistency of the requirement is conducted by developers and customers mutually. Common, well-defined types of projects are candidates for this way of requirement elicitation. System analyst should understand what is the problem, its nature and extent in requirement analysis phase, no matter what technique is being used. It is of critical importance that a representative cross-section of users should be interviewed. That means all segments of the customer should be represented in the meeting so that views of all can be recorded. Facilitated application specification technique, commonly referred to as FAST, is another requirement elicitation technique. It is observed in the software industry that sometimes customers and software engineers do not work cooperatively. FAST technique encourages the creation of a joint team of customers and developers who work together to identify the problem, propose solution, negotiate different approaches, and specify preliminary set of solution requirements. In FAST technique, emphasis is on team. Meetings are coordinated by usually a third-party consultant who is experienced in conducting and moderating such type of meetings. FAST meeting is attended by both the customer and developers who work as team. Meetings are as matter of common practice held at neutral venues where both customer and developers attend it. Agenda and rules for participation of meeting are decided before the meeting and circulated among participants in advance. Facilitator moderates the FAST meeting. Quality function deployment, commonly known as QFD, is a quality management technique that is used to translate the customer needs into technical software requirement. QFD technique attempts to maximize customer satisfaction by tailoring the software process according to the requirements of the customer. In QFD approach, it is of utmost importance to know what is valuable to the customer, an order of these values starting from most valuable to less valuable. Once customer priorities are known, they are incorporated in software development process so that software, when developed, should embody those value characteristics. It uses customer interviews, observation, and historical data for information gathering. First, we will discuss some broad guidelines for analysis of requirements. The first guideline states that the environment in which software will be deployed and used must be well represented and understood. The second guideline is that the functionality of the desired software must be defined. The third guideline is the behavioral aspect of the software as a consequence of the external events must be clearly represented. The fourth guideline is that the information, functional and behavioral models must be partitioned in a manner that they show the layers or hierarchy of the desired system. The fifth and last guideline states that the analysis process should begin with essential information and gradually move towards implementation details. Dear students, let us now study the application of the principles we have just studied. First three principles require that we develop models. Models are created to get better understanding of the entity to be developed. Data model, functional and behavioral models are created to get the clear understanding of desired system. The models must represent the data which is to be transformed by the system, the function which will transform the data, and the behavior of the system when transformation is taking place. First principle emphasizes the need to understand the information domain. In order to understand information domain fully, data model is created. Details of data model will be discussed in Unit 5. Data model contains three different views of the data. Information flow. Number 3. Information structure. First view, information content and relationship, represents individual data items which are either consumed or produced by the system and how these data items are related with each other. Second view, the information flow, represents the manner in which data items move through the system. The third view, the information structure, represents the internal organization of various data items. Second principle requires that functional model should be created. In functional models, focus of the software engineer is on the problem-specific functions and sub-function. Prototyping is another technique for requirement gathering. Remember, prototyping does not make meeting and interviewing, FAST and QFD techniques redundant or unnecessary. Rather, it supplements those techniques. We have studied prototyping in the unit number 2, that was from the perspective of process model, but here we will see a specialized application of the prototyping process model as a tool which helps both customer and development team reach common understanding of the requirements of the desired software. The prototyping approach almost always assumes that the model will be a working model, that is, a collection of computer programs that will simulate some or all of the functions that the user wants. But since those computer programs are intended just as a model, there is also an assumption that when the modeling is finished, the programs will be thrown away and replaced with real programs. Good candidates for a prototyping approach are projects that have the following characteristics. The user is unable or unwilling to examine abstract paper models like data flow diagrams. The user is unable or unwilling to articulate or pre-specify his or her requirements. The system is intended to be online with full-screen terminal activities. Almost all prototyping software tools are oriented toward the online, database-driven, terminal-oriented approach. The system does not require specification of large amounts of algorithmic detail. Good candidates tend to be the systems in which the user is more concerned about the format and layout of the data entry and output screens and error messages than about the underlying computations performed by the system. The prototyping approach certainly has merit in a number of situations. In some cases, the project manager may want to use the prototyping technique for requirement gathering. Quality of software, among other things, depends on how requirements are specified. complete, correct, and consistent requirement specification will ensure that right product is being developed and vice versa. Dear students, let us study now some basic software requirement specification principles. Requirements, no matter how specified, are viewed as representation process. Well-represented requirements will lead to successful implementation of software. Now we discuss software specification guidelines. Number 1. Functionality and implementation should be separated. At the requirement analysis stage, the focus ought to be identification of what is required. Thinking it is going to be accomplished at this stage is premature. It will only create confusion and hamper the quality of requirement analysis and specification. Number 2. Desired behavior of a system should be represented by appropriate model. The model should encompass data and functional responses of a system to various inputs. This exercise will increase the understanding of the working of the system. Basically, it will identify, given certain input, how system will respond. Number 3. The domain in which software will operate should be specified. The interaction among domain component and software should be clearly specified. This means the task software is supposed to perform should be clearly understood. Suppose software uses a database which is located on an independent data server and data server crashes, then this failure should not be attributed to the particular software. Number 4. Mostly software is part of a large complex system consisting of hardware, software, people and data. How change in any one of these will affect the overall system needs to be identified during specification. Number 5. Create a cognitive model rather than design or implementation model. The cognitive model describes the system as perceived by the user community. Requirement specification must be mutually approved by the software development firm and the customer. The next topic is how to document the software requirement and specification, SRS. Software requirement and specification, commonly known as SRS, is a document which is produced at the end of software requirement analysis phase. SRS usually contains these: introduction, information description, functional description, system behavior, performance requirements, design constraints, validation criteria. The introduction section contains the purpose, scope, and the overview of the desired software. Information description gives complete details of the problem for which software is being developed.